Alright, here we're given a couple of problems from a checkpoint about angles and their relationships. So let's read the first question and see if we can come up with an answer for it. Alright, so it says that the two angles whose measures are given below, so measure ABD is this, and measure BDC, we'll do in blue, these nice spring colors, is this. These are the two measures, and it tells us that they're complementary. Complementary. What does that mean exactly? That's going to be key. We're going to have to know. And then it asks us to find the measures of the angles. So the problem is right now there's variables, right? There's a y in there. This angle is 5y plus 1. And the second angle is 3y minus 7. We don't want to have variables in there. We want to know what the exact degree is as a number. Well, the clue that it gives us really is that they're complementary. Now, complementary angles, and we don't spell this like compliment like I'm saying something nice to you, or there would be an I in it, but complementary angles always add up to a certain number, and that number is 90. So they form a right triangle together, okay? Add up to 90 degrees. They always do. So that means that we can set up an equation. We know a hint about this stuff. We know a clue about this stuff. So we know that if we take this first angle, the 5y plus 1, and then we add to it the second angle, the 3y minus 7, just taking one angle and adding the other, since they're complementary, they have to equal 90 degrees. So we can set that equal to 90. From here, we've got an equation set up that we can solve, right? We can just combine the 5y and the 3y. That will give us 8y altogether. And when we combine the positive 1 and the negative 7, we get a negative 6. And nothing happened on the right side. We didn't combine anything. It's just 90 all by itself. So we'll leave it as that. The second to last step, well, maybe I shouldn't say second to last, but one of the final steps is to add 6 to both sides. And we will soon find out that 8y is equal to 96. Which means that when we divide by 8 on both sides, we find out that y is equal to 12. Are we finished? Is that it? Ooh, we have to look back at the question and remember that we're supposed to find the measures of both of these angles. So we know we're going to have two answers, and we just found out what y equals, the variable. We didn't find out what the actual angles are, so we still have to evaluate that. That means that word evaluate means we need to take the 12 and plug it back in for y in both of these equations. So the first equation, it says 5y plus 1 is what that measure of that angle is. That means first I better take this 12 right here and plug it in for the y. So now when I rewrite it, I'm going to have 5 times 12 plus 1. And that's going to equal 5 times 12 is 60, plus 1 is 61. So we've got an answer for the first measure. It's 61 degrees. Now we can similarly do that for the second angle, which you can jump ahead of me and do that if you figured that out already. Let's stick to our color pattern. So for the second angle, we're doing this nice Easter blue. We have 3y minus 7. And I'm going to take that same 12 because I know that 12 is the same thing as y, and I'm going to plug it right in here for this y. And I'm going to get that 3 times 12 minus 7 is going to be the angle, the measure of the second angle, which is 36 minus a 7 will give me 29 degrees. So that measure we can write as 29 degrees, and we have our second answer. Now, if we did things right, we should get two angles that add up to how many degrees? Because they're complementary. That means these two angles should add up to 90. So let's check. Does 61 plus 29 equal 90? It does. So we can feel good about ourselves. We got that part right. Okay, now we're going to move on to the next question below that's listed. So give me just a second to... Okay, I'm back. And we're going to take a look at the second question now. I cleaned up the workspace. And the second question just gives us a picture with a bunch of angles. So this would be angle 5, angle 1, 2, 3, and 4. They're all just labeled with numbers. They could have used letters if they wanted, but that doesn't mean that this is 1 degree or 2 degrees or 3 degrees. That's just how they labeled the different angles, right? Okay, so we're asked a question to tell whether the angles are only adjacent. What does adjacent mean? We should be thinking. If they're adjacent and form a linear pair, what's a linear pair? Or if they're not adjacent at all. And then the two angles that it gives us here, and I'll circle them in green, are angle 1 and angle 5. So these are the two we're comparing. This one here and this one here. So, first question, are they adjacent? Well, if two houses are adjacent to each other, what does that mean? Are they across? Are they opposite? Are they right next to each other? I just got the answer correct. They are right next to each other. That's what adjacent means, that they're going to be sitting right next to each other. So when we first look at these two angles that we're comparing, angle 1 and angle 5, we ask ourselves, are they next to each other? Certainly. There are no other angles in between. Angle 1 and angle 5 actually share a side right here. Do you see that? That's crucial for being adjacent angles. So we know they're adjacent. That's the first part. The second part is, do they form a linear pair? So we need to know, what is a linear pair? A linear pair, well, let's first think of this word pair. How many things are going to be involved when we're talking about a pair? A pair of shoes, you have two shoes in each pair, correct? So we're going to have two angles, we know. We're just looking at, which is what we have already. And then we have this word linear. So what word do we see in linear? We see this word right here. We see line. So this means, a linear pair just means two angles that form a line together. How does that work? Well, I could draw a line. I could work backwards. Let's draw a line. And then I could make an angle here. And that automatically makes a second angle here, you'll see. And these two angles, this one here, we could call this angle A, and this angle B. They definitely form a line together, don't they? Right here. When we put them together, they form a line, or 180 degrees. So, for a linear pair, we go back to our question and ask ourselves, is angle 1 and angle 5 a linear pair? Do they form a line together? And you bet they do. They form this line right here. I'll trace it. Angle 1 and angle 5 together do the same thing here that angle A and angle B are doing. They're forming a line. So, we know the answer to our question is, we have adjacent angles that also form a linear pair. So, I hope that's helpful to you. If you have any questions, go ahead and leave them in the comments. I'm happy to get to them. And take care. Good luck with all of your math endeavors.